Is it still running?
Hi Ian, it's Trey.
Hey, it's Cortland, and today we're going to talk about diodes. So, right here we got a brief overview of the breadboard. So, here's where our input's coming from. It's coming from the digital, and here's our ground, voltage. And the first one is simply the most simple thing you can do with the diode. So, it comes in through the P side right here next to the N side. This is the voltage input, and through the resistor it goes out to ground. So we use this one in order to test the response, the current as a function over the voltage input. So the second one right here is the half wave rectifier. So what it does is the voltage comes in through here, comes through the diode, and right here you have both a resistor going to ground and also you have a capacitor. Now what the capacitor does is it sort of sends some feedback. And so basically it stops it from completely dropping off, and of course since the diode is one way, it can't really produce a negative voltage as it would if it was a straight shot. And right here we got an op amp, and as you can see these two wires, this is the positive voltage, this is the negative voltage. So voltage comes through here, this is the negative terminal of the op amp, it goes through here. The diode serves to produce the feedback, so it comes back this way, and here's the positive input. So magnified through both the negative and positive, but the rest of the feedback goes through ground. All right.
So now we'll talk about the corresponding waveforms that we got for the various circuits setups. So here, as he demonstrated, the most simple thing that we could do, that first circuit, these are the corresponding relationships that we got for the diode current and the voltage drop. So here, as you can see, the data went a little bit haywire here, but the general shape of the curve makes sense for the diode current versus the voltage drop that we got across the diode. And then if we move on to part B, we see how the half-wave rectifier varies depending on whether or not there is a capacitor in the circuit or not. So pretty much what the half-wave rectifier does is make sure that half of the input signal is not accounted for in the circuit, and that's pretty much what we see here. We see a slower drop off in the current when there is a capacitor, and then without, it drops off faster. And then for the last circuit setup that we see with the active rectifier, we see that the slew rate increases or decreases when we have a greater frequency input signal, and that is demonstrated right here. And pretty much how we calculated the slew rate was to see how the voltage changed from here to here over that given amount of time.
Right, I think we're good. Cortland Morse here.
Peace out, Ian.